I'm Andrew Smith from the Open University Cisco Academy, and in this video I'm going to be talking about Module 4, InterVLAN Virtual Local Area Network Routing from the Switching, Routing and Wireless Essentials, which we teach on TM257. As ever, I am not going to read through the slides verbatim. You're able to do that quite comfortably yourselves. What we're going to do is explore the interesting topic of inter-VLAN routing. In the last module, we looked at how VLANs segment broadcast domains and make smaller networks within a switched environment for security, for control, for management, and for many, many other reasons. And we actually use it as part of the Cisco and other vendor application of voice over IP technologies. What this allows us to do is obviously get the layer 2 devices to talk to each other, but they cannot see each other outside of their VLANs. And we might want to set up VLANs that we can route between, set up firewalls and access control, maybe set up a VLAN for servers, have finance, talking out to the internet, a DMZ or such like. And basically by using inter-VLAN routing, we can actually then get traffic to move between them and do a sort of a range of solutions. Now, you can set up a Cisco switch to be a layer 3 switch. The 3550, 3560s you will find in Packet Tracer can do this. And I gave an example way back in the introduction to networks where I actually built something using switches and turned on IP routing. Or there is what's called router on a stick, where you stick a router as a sort of stub, and you have the whole switched network below it, and then you have a router passing traffic up and down through what are called sub-interfaces. So originally they would have had a router with multiple Ethernet interfaces, and we would have routed between those Ethernet interfaces. That's kind of logical. So you're basically strapping down the router, and you can actually do that and make a multi-port router. And you can technically still do that. And some of the Cisco routers, you can actually put in a switch port, turn it into router ports, and then route between those interfaces as well. However, there are costs involved in that, and it can be clunky, and it can be a little bit problematic from a configuration setting. Inter-VLAN routing relies on .1Q trunking, 802.1Q from the IEEE standards. And basically it's an open source requirement. All manufacturers will handle it, and it basically tags each of the frames with a additional VLAN identifier. It injects it in. It just makes that frame technically can be a little bit slightly bigger, and put that additional information in. So as the switch passes it, it knows now to send it to which VLAN, and it passes it to a router. It knows which other VLAN to send it to. However, what Cisco note is you shouldn't do it for more than 50 VLANs for performance reasons. You're going to have a lot of bandwidth now on the line, and if you're actually sending 50 VLANs up a pipe, I think you've got a bigger network, and you need to actually have better scalable network infrastructure settings, and actually have a proper multi-layer switching solution, or learn the CCNA. Okay, so at that stage, if you're doing that many, and most of the examples we will ever give you, it's 3, 4, no more than 10. And that is really what you would be doing in a small premises or branch network in an organization. And if you've got 50 VLANs, you're a large corporation anyway, or getting to be a large corporation. So basically we can actually also set it up on InterVLAN routing on a layer 3 switch. We have to turn on IP routing, but then we set up the SVI, set up an ID on that device and then actually switch there. But you need special layer 3 switches to do it, or models that have got that additional feature within their data plane. And as I say, in Packet Tracer, the 3550s and 3560s will actually handle it for you. Faster because it's now happening on the switch. Faster because there is no data throughput on the cable. Faster because there is no challenge of bandwidth or load. But slower because actually a router is very fast at routing and a switch is very fast at switching. So actually it's the best and slightly not so good of both worlds. So whilst they are talking about the advantages, you do need to look at all of your performance requirements. So you can look at the performance, and if you've got a routing solution where you've got a mission critical system, sometimes it's actually combining different routers with switches to do that and to do that adequately. So we're going to look at router on a stick. That's the one Cisco likes to teach you, and it is a good one to learn because actually once you get your head around this, you actually learn a lot of new commands and you learn a little bit more about how real networking works. And to add to that, in the day school, which is part of the end of module assessment, if you are a TM257 student, that you will guess what you're going to be doing, and you are going to be doing InterVLAN routing, and we will be setting you a challenge based on a randomly allocated variable length subnet that your day school tutor will give you. But basically, with the router on a stick scenario, all the routing happens on R1. So anything that is going from switch 1 to switch 2, if it's VLAN 20 or VLAN 10, has to go via the router. So it has to go up and then back down again. Okay, there is no way about it. So even if they're adjacent, it has to go out, up, and back down again. And it's almost like a sorting office if you were to use a post office or post box analogy. So they cannot ping each other because they're in separate VLANs, but as soon as we set up InterVLAN routing using a router on a stick scenario. Now to accomplish this, and my images just clumsily across here, we actually have to set up something called a sub interface. And to accomplish that, you can actually put multiple interfaces on a Cisco router, and quite a large number actually. So what you do is you physically allocate one interface, then you actually apply multiple sub interfaces, which gives each one a different IP address. To accomplish this, there are 4 steps. Create and name the VLANs. Okay, we will give them names, or Cisco will give them names. Create a management interface. Configure access ports. Configure trunking ports. Okay, and this is how to set up a switch on a network. And here you've got an example that you can see we've set up the VLANs, named the VLANs. We've now put IP addresses on the VLANs. On VLAN 99, which is the SVI and the default gateway, and then we've told them which ports to actually set up. So port 18 and port 1. Port 18 set to access VLAN 20, and port 1 is set up as a trunking port. Now, you did see in a previous example, you can just do on an interface, interface FA018, switch port access VLAN 20, and it will automatically allocate it. So they are just teaching you the long way but good practice that you can set up your own VLANs without necessarily immediately applying it to an interface. To set up a sub-interface, all you have to do is use the interface and a dot and a sub-interface number. Convention is, if it's VLAN 10, do .10. If it's VLAN 100, do what .100. You don't have to, You can use different numbers if you want, but convention is not a bad thing because you're like, ah yes, it's .10, so it must be VLAN 10, and we can see this accordingly in this setup. So what we've done here is just switch it on, and as soon as you type in interface blah 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 dot number, it will create that sub interface for you. And the really nice thing then is you then say, I'm going to set up the encapsulation .1q and do the VLAN tag, and then we will give it an IP address. And then all we do is we bring up the parent interface, and once we know shut that, everything else will actually run accordingly. You can shut down sub interfaces, so you can do shut or no shut and stuff like that. And then you can set up routing locally, whether it is static routing or a other dynamic routing protocol. Remember, Cisco router is route connected, so in some of the scenarios you don't need to set up routing because they are connected. If it's going up and down on the same interface, it will automatically route them for you. And sometimes machines get really anxious about that. Well, there's no routing command. Well, that's because Cisco will always route connected between interfaces. Even sub-interfaces, it's still on an interface. Therefore, it will route those connected interfaces for you. And yeah, it is quite straightforward. So you see there, .10, VLAN 10, .1Q 10. Okay? .20, VLAN 20, .1Q20. So it's convention. I could have had .100 VLAN 10. Bit silly, why would you do that? And I think sometimes convention is very meaningful. And here it is very helpful. You're not required. It's not going to be a pass or fail requirement. It's more, in our assessment, have you gotten it to work? But you have to remember the poor person marking it, she or he, may have to look at this and try and work out what you're doing as well. So sometimes trying to be too clever doesn't help the poor person that's marking it for you either. So stick to convention. The sub-interface should be the VLAN. And then, as you can see from the example, you're able to ping between the devices on this scenario network that they've created. And you can use all the standard commands. Show IP route will show the sub-interfaces. Show IP interface brief will show all the sub-interfaces as well. And obviously with the show interfaces you show all the information and actually show the trunking, the tagging that's taking place. And obviously on a switch you can then do the show VLANs. My advice? Here you should do the packet tracer activities. Here they are quite useful. You will benefit from them. And of course, we're talking about layer 3 switches. You can also do it with layer 3 switches. But don't forget, you need to turn on IP routing. Some of the live rail equipment will have it turned on by default. On Cisco iOS images for 3550s and 3560s, you must turn it on. And once you've actually turned it on, you can actually then set up the VLANs and then set up the .1Q and any local routing that's required. So you set up the VLANs, the SVI, and configure the access port. And as I've already said, you've got to turn on IP routing. If you don't do that, it just won't happen. You haven't told it that it's actually got to perform that function. It's switched off by default on some devices as a memory saving or resource saving overhead. Then, just to verify it, you can use ping and you can use ARP and you can use other resources accordingly. It will do that. And you can then easily route between interfaces. And I gave an example back in ITN where you just turn off the switch port by doing a no switch port, and then you can actually give it an IP address, and then that acts as a routing interface. And you actually set up static routes or OSPF or RIP or any other routing protocol. Now, they've introduced this quite early because OSPF isn't really discussed until the enterprise networking course. But here you at least get an idea of what you need in order to make it happen, which is fair enough. And I think sometimes it's just good to see ahead. So in this example, in the practical labs, when you do the packet tracer activities, then you can easily sort of test it using the show IP route or show IP interface brief on a switch as well, and it will perform equally the same way. And there is a great packet tracer activity for you to do that on as well. Lots of packet tracer activities. To troubleshoot, basically just show VLAN or show VLAN brief, and it'll give you a good summary of what VLANs and what ports are allocated and where you've put the ports. And then if you do show interface trunk, that will show you what is trunking or what VLANs are being passed. But do show run as well, because sometimes you flick up at the config and realize you haven't allocated a specific port to a VLAN, or you've misconfigured the allowed command on the trunk interface. Okay, and that way you can then check the interface to switch port, show running config again this time, or even do an IP config on a device, or do show IP interfaces brief. You've got to be systematic. You've got to check that they're all matching, that the VLANs, the trunks, and the interfaces are all in the right VLANs pointing in the right direction. So finally, practice, practice, practice. I'm going to give a demonstration of InterVLAN routing in a separate short video. My advice is to actually do all of these additional packet tracer activities and do the troubleshooting as well as the configuration, and get used to building up a good base of practice-based resources, and be mindful that we actually have this as part of our final day school, which is a practical that is linked to your under module assessment. So I've been Andrew Smith from the Open University Cisco Academy. This is a subject I've covered quite quickly, but it's best done through the practicals. The more you do the hands-on, the more straightforward it becomes, and I will commend to you, do the packet tracer activities and do watch a video when I'm setting up my own InterVLAN routing using a couple of different technologies.